Hello friends and welcome to another lecture on operation research. Today we will learn about simplex two-phase method. This is Professor Arvind Prasad. For this, let us take up a problem. The problem is on your screen, and as you can see, the constraints, that is the constraint 2 and the constraint 3 especially, they have a greater than equal to sign or a equal to sign. Now, such problems are solved using the big M method. In the two-phase method, it's just a modification of the big M method. So let's get ahead. First, of course, like in the big M method, we have to introduce the slack, surplus, and the artificial variables. So the slack variable is x3. The surplus variable is x4 and x5 and x6 bar are the artificial variables. Like in big M method, of course, I have discussed the big M method and you will find the link of the big M method in the right hand top. We write the objective function now as z is equal to 2x1 plus 3x2 plus mx5 bar plus mx6 bar. In the big M method, we start from here. But in the two-phase method, we take a slightly different approach. What we do is we take this objective function and divide it by m. Now, once we divide it by m, we can neglect 2 by m and 3 by m because they are very small numbers. Now, m here is a very, very large number in big M method. So, therefore, if you divide by m, 2 by m and 3 by m, they can be neglected. So now we get a new objective function w, which is w is equal to x5 bar plus x6 bar because m by m is 1 and m by m here also is 1. And we have neglected now 2 by m and 3 by m. Now we have to minimize w is equal to x5 bar plus x6 bar. The phase 1 of the problem is that of minimizing w using the simplex method. Okay, so x5 bar and x6 bar, remember one thing, they are positive. So w will be minimum only when x5 bar and x6 bar is equal to 0. So we have to use simplex method in such a way so that we get x5 bar and x6 bar as 0. So we set up the simplex w for the problem. Remember one thing, we have to minimize w is equal to x5 bar plus x6 bar. This is just like maximizing minus w is equal to minus w plus x5 bar plus x6 bar. Because what we have done is we have just multiplied the minimizing objective function by minus 1 on both the sides. So it becomes a maximization problem. There we have the simplex w now. The coefficients of x1, x2, x3, x4 is of course 0 and that of x5 bar and x6 bar in the objective function is 1 and 1. Below this we have noted the coefficients of x1 to x6 bar in all the three equations and the RHS of the equation is written here. The basic variables are x3, x5 bar and x6 bar. Now, since x5 bar and x6 bar are basic variables, we have to see that their coefficients in the objective function, that is the rho 0 is 0. So for this, we do rho 0 minus rho 2 minus rho 3 and we update our simplex w. Now we can start with our iterations. So remember one thing here. I will be using the matrix method to solve this problem. The usual method for solving the simplex w is to use row operations, but I prefer using the calculator. It's simpler, it's faster, and the chances of error reduce. So let me start my calculator. Okay, so let me maximize my calculator here. There we are. Let me pin it so that I have it permanently over my slides. And there we are, current slide. Yes. So the first thing that you do whenever you have your calculator, this is of course a simulator of the same calculator FX 991 ES. So if you have this calculator, you can follow the calculation along with me. Then in one stroke itself, you will learn how to use this method. So the first thing that you should do in this calculator is go to mode and press 1. Now, why have I done this? I have done this because I would like to delete all the previous matrices and any other entries that I have done in the calculator. Now we start entering the matrices. Now B is the coefficient matrix of the basic variable. A is the coefficient matrix of the non-basic variable. And B, of course, is the RHS. C is the row 0 coefficient of the non-basic variables. And CB, of course, is the row 0 coefficient of the basic variables. Okay. In this method, you have to enter A and B only once in the calculator. You will also enter B, that is the big B, and you will update it in each iteration. Isn't that simple? It is. Let's do it. So go to mode 6 and go to 6 and select matrix. Let's enter matrix A. So 1. Select 3 by 3. So 1. That is 1, 0, 0. And that is 0, 1 and 1. Okay, I'm sorry. I started entering matrix B. I should have entered matrix A. So matrix A is 1 divided by 2. 1 divided by 4, 0, 1, 3, minus 1, and 1, 1, and 0. Now we are pretty much done with entering matrix A. Now let's enter matrix B. So we go to mode and we go to 6 and we go to 2. And then we select a 3 by 3 matrix and that's it. 1, 0, 0, 0, 1, 0, and 0, 0, and 1. Matrix B has been entered. Now we have to enter small b. For this we do mode 6 and we select mat C. So that's 3. Now remember one thing, this is a 3 by 1 matrix. As you can see here, in this calculator, we cannot enter a 1 by 3 matrix. So we cannot enter matrix C and CB. So let's go ahead with entering matrix B. So that's going to be 3. And that's going to be 4, 20, and 10. We are done. Now let's get ahead solving it. So remember one thing, I have copied the simplex table once again. The entering basic variable is x2. You all must be aware why it is x2, because it has the highest negative coefficient and the leaving basic variable is x5 bar. You would be aware, but I'll repeat it once again. What you have to do for the leaving basic variable, you have to take the RHS and you have to divide it with the coefficient of x2, that is the entering basic variable. So that's going to be 4 divided by 1 by 4, 20 divided by 3, and 10 divided by 1. Now the least will be 20 by 3. So x5 bar will be the leaving basic variable. Now the coefficients of leaving basic variable, okay, are 0, 1, 0, which is in matrix B. Now what you have to do is, in the matrix B, you have to replace the coefficients of x5 bar with x2. So now the updated B is 1, 0, 0, 1/4, 3, 1, and 0, 0, 1. That is all you need to update in each and every calculation, and all the other calculations are done by the calculator itself. Isn't that simple? Yes. So let's do it. Mode 6. Let's go to B. And let's go to 1. Now we need to update it. So this is going to be 0.25, 3, and 1. We are done. Now the updated coefficient of row 0 for this calculation, that is the first iteration, is going to be 0, 4, 0, because x5 bar now is replaced with x2. So let's get ahead. So the updated coefficient for row 0 for the non-basic variables is given by CB into B inverse into A minus C. Now, as I told you, we cannot multiply a row matrix to any matrix in the calculator. Okay. So what we do here is, the trick is to find B inverse minus A. So we do that. Shift 4 multiplied by, again shift 4 and select 3. And lo and behold, you have got B inverse A. So we write it down here. We all know that if we multiply this row matrix with this square matrix, which is pretty simple, you are going to get 4 by 3, 4, and minus 4 by 3. From this, you have to subtract the original C, that is 2, 4, and minus 1. And there we are. We get the updated coefficients for row 0 for the non-basic variables, that is x1, x2, and x4. Now the updated coefficient for the basic variables is found by taking CB and multiplying it with B inverse. To get B inverse, you have to do shift 4 and 4 and take the inverse. There you are. Now, of course, if you go here, it says it's minus 1 by 12, and that's minus 1 by 12 here. We all know that if we multiply this row matrix with this, we get 0, 4 by 3, 0. There we are. So the updated coefficients for row 0 is minus 2 by 3, 0, 0, minus 1 by 3, 4 by 3, and 0. So we know this is not the optimal solution. That is, after first iteration, we are not going to get the optimal solution. You have to do further iterations. Why? Because you have negative minus 2 by 3 and minus 1 by 3 in row 0. So after the first iteration, you have the table which is on your screen. Now the updated A, that is the coefficient matrix of the non-basic variables, is found by B inverse into A. And the values of that has been entered in white. That is, the non-basic variables are x1, x2, and x4. Now, how do we get it? We have already got it in the previous slides. So let's have a look at it. So B inverse into A, we have it here 0.4166, 0.0833, blah, blah, blah. So we merely copy it down and enter it here. Similarly, the updated B is going to be nothing but B inverse. We already have it on the calculator here and we enter it here. It's entered in yellow. And the updated small b, that is the RHS, is going to be nothing but B inverse into B. So we already have B inverse here. So let's do it once again. That is updated B here. So let's calculate it. Shift 4, Shift 4 and 4 inverse into Shift 4 5, and there we have it. So the first entry is 7 by 3, it's 7 by 3 here. The next entry is 20 by 3 and the third entry is 10 by 3. Now it's very evident here. The entering basic variable is going to be x1 because it is the highest negative entry here, and the leaving basic variable of course is going to be 0.4166 divided by 7 by 3, then afterwards 20 by 3 divided by 0.333 and 10 by 3 divided by 0.666. Now you can figure it out for yourselves using your own calculator. The leaving basic variable is going to be x6. So the entering basic variable is x1 and the leaving basic variable is x6 bar. So all you have to do now is go back to the calculator once again and update your B matrix. Now your B matrix is going to have x3, coefficients of x3. It already has the coefficients of x2. Now since x6 bar is the leaving basic variable, its coefficients in matrix B are replaced with x1. That is the entering basic variable. So we go to 6, we go to 2 and we go to 1 and we update it. So that's going to be 0.5, that's going to be 1 and that's 1. Okay, and that's 1. So we have 100, 0.2531 and half 1 1. We are done. Now once again we find out the updated row 0 coefficients, that is C. For this once again we have to find B inverse into A. So this is going to be shift 4 4 B inverse into shift 4 and 3. There we are. So if we multiply 0, 4 and 2, which is now going to be the updated CB. Remember the updated CB now is going to be 0, 4, 2. Now why this 2 has come here is now because the updated matrix of row 0 for the basic variable is going to be x3, x2 and x1. Why? Because x6 is out and x1 is in. So if we multiply 0, 4, 2 with this, we get 2, 4 and minus 1, minus 2, 4 and minus 1, and you have 0, 0 and 0. Now the updated CB, we do the calculation similar as the previous. Now for this, what we have to just do is find out B inverse. So we find out B inverse here, 4 B inverse, there we are. Okay. Now if you multiply 0, 4, 2 with this, we get 0, 1, 1. So now the row 0 coefficients are 0, 0, 0, 0, 1 and 1. Which means now we have received, after iteration 2, we have reached the optima for W. Because there is no negative coefficient in row 0. So the solution, optimal solution, of course, will be B is equal to B inverse into minus B. So that's it. Shift for for B inverse shift for mat C. That's, and which is nothing but your basic variables now updated after x6 bar was out and x2 came in. Your updated basic matrix now is, or basic variables are x3, x1 and x2. So your solution is x3 is equal to 0.25, x1 is equal to 5 and x2 is equal to 5. Remember one thing, x5 and x5 bar and x6 bar, they are 0. So W or minus W plus x5 bar plus x6 bar is equal to 0 is 0. That is W is 0. That is W is minima. Of course, to find the coefficients of x1, x2 and x4, we have to take B inverse into A. So let's do this. So shift 4 B inverse into shift 4 A. That is 3. So there we are. Now the coefficient, this is the coefficient of x1, this is the coefficient of x2, and this is the coefficient of x4. I have noted it down here. Similarly, the coefficient of x3, x5 bar and x6 bar can be found by getting the B inverse. So let me make the correction here. Okay, B inverse. B inverse. There we are. Current slide. Yeah, there we are. So that's going to be B inverse. So that's it. So shift 4 and 4 and the inverse of that. So we have this. Now what we do is we have reached the optima for phase 1. Now for phase 2, we can start with the phase 2 now. Once we have reached the optima of phase 1, we can start with phase 2. So for phase 2, the original objective function is this. Now x5 and x6 already, they are 0. So all that remains is to minimize this or to minimize this. That is, if you multiply this equation with -1, you have to maximize this. That is minus z plus 2x1 plus 3x2 is equal to 0. So we prepare the simplex tableau. That is, we copy the simplex tableau prepared here, but we drop x5 bar and x6 bar. Right? And of course, we enter the coefficients of z. So that's 2 and 3. Now again, remember one thing here, x3, x1 and x2, they are the basic variables. We have got that these are the basic variables from the previous phase. Now the coefficients 2 and 3 have to be made 0. Why? Because these are the basic variables. For basic variables in row 0, the coefficient should be 0 to start with. So we have to do the row operations to eliminate it. And there we are. Once we have done this, what do we find? We find that all the coefficients in row 0 are 0 except for x4, which is minus 0.5. Remember one thing, this is a maximization problem. Now, if we try to do a further iteration in the direction of x4, that is, in the maximization problem, always whenever we choose a entering basic variable, we are doing a increase in that direction of the particular variable. Now, if we do an increase in the direction of x4, it's going to be negative. It is going to reduce the objective function. So therefore, this minus is an indication that we cannot go in this direction. Therefore, this is the optima. Right? Now remember one thing, all of you must be raising your ears. Oh, it's minus 25. The maxima is minus 25. Remember one thing, z is minus 1. So it is z is equal to 25. So that's the maxima. Now x4 also is 0. Why? Because in this table now x4 is the non-basic variables. The basic variables are x3, x1 and x2. So we have reached our optima. So the answer is x1 is equal to 5, x2 is equal to 5 and x3 is equal to 0.25. That's the end of my lecture. Thanks for being patient and being listening to me. I'm sorry. Thanks for being patient and listening to me. If you have any queries, do write it in your comments. Now, this video was in response to one of the requests put by one of my viewers that, sir, make a video on two-phase method. Initially, I thought over it, the BigM method can be done in the calculator. Yes, it can be done in the calculator and it can be done in a very easy fashion. But the two-phase method has an advantage that the M is eliminated altogether and you have simple numbers to deal with. So the calculations become much simpler. Goodbye, friends. Have a great day and have a great time. And do keep putting your requests and your comments on my videos on what you want exactly. I mean, in which topic in OR you want your video. I'll make it for you. It might take a little time, but then this channel has been opened so that I can share my ideas and my knowledge with all my students. Bye, friends.